China is moving faster than almost anyone expected in the race to build humanoid robots. Just a few years ago, robots that looked and moved like humans were mostly experimental machines that struggled to walk without falling. Many of them needed support frames to keep their balance, and even the simplest movements required careful programming. Because of these challenges, many researchers believed humanoid robots would take decades before becoming useful in real-world environments. But something changed. Across China today, robotics companies are developing humanoid robots that can walk, balance, carry objects, and even learn from experience using artificial intelligence. Some of these machines can climb stairs, recognize objects, and move through complex environments without constant human control. In demonstrations, they perform movements that look surprisingly human, from running and lifting boxes to navigating crowded spaces. The surprising part is not only how advanced these robots are becoming. The real surprise is how quickly the industry is moving. China is now building humanoid robots at a speed that is attracting global attention. Robotics companies are expanding their production lines, research labs are experimenting with new AI systems, and engineers are improving both the hardware and the software that power these machines. Instead of producing only a few prototypes each year, some companies are preparing to manufacture thousands of robots. And this could mark the beginning of a major shift in how machines interact with the human world. For decades, robots were mostly confined to factories. Industrial robots were designed to perform repetitive tasks such as welding metal, assembling electronics, or transporting materials along production lines. These machines were extremely precise and efficient, but they were also very limited. Traditional industrial robots followed strict instructions programmed by engineers. They performed the same task over and over in controlled environments. If something unexpected happened, like an object being moved slightly out of place, the robot might stop working completely. This happened because traditional robots had almost no understanding of their surroundings. They did not see, interpret, or adapt to the world around them. They simply executed instructions. Artificial intelligence has changed that. Modern robots are now equipped with cameras, sensors, and advanced processors that allow them to analyze their environment in real time. AI systems help robots recognize objects, detect obstacles, and adjust their movements accordingly. Instead of following rigid instructions, robots can now make decisions based on what they observe. This shift from programmed machines to intelligent machines is one of the most important developments in robotics, and humanoid robots represent the most ambitious version of this technology. Humanoid robots are designed to resemble the human body. They have 2 arms, 2 legs, and sensors that allow them to perceive the world. Engineers build robots this way for a simple reason. Human environments are designed for humans. Buildings, tools, machines, and infrastructure are built around human movement. Doors, stairs, tools, and equipment are all designed for the human body. If a robot has a human-like shape, it can potentially work in these environments without major modifications. This flexibility makes humanoid robots extremely powerful. Instead of performing only one specialized task, a humanoid robot could potentially perform many different types of work. It could carry objects, operate tools, inspect equipment, and assist humans in a wide range of environments. But building such machines is extremely difficult. Maintaining balance on 2 legs requires extremely precise coordination between motors, sensors, and control systems. Every step requires thousands of micro-adjustments to maintain stability. Even slight errors in movement can cause a robot to lose balance. For decades, these challenges slowed the development of humanoid robots. But advances in artificial intelligence, sensor technology, and computing power are now allowing engineers to solve many of these problems. Machine learning algorithms allow robots to learn from data collected by their sensors. Over time, robots can improve their ability to balance, navigate environments, and manipulate objects. This learning capability is one of the reasons humanoid robots are improving so quickly today. China has recognized the strategic importance of robotics and artificial intelligence. The country has invested heavily in both technologies, creating an ecosystem where robotics startups, universities, and research institutions work together to develop new machines. One company receiving significant attention is Unitree Robotics. Unitree has developed humanoid robots capable of walking, balancing, and performing dynamic movements. In demonstrations, their robots have been shown running, jumping, and performing complex movements that once seemed impossible for machines. Videos of these robots performing agile movements have spread widely online, capturing the attention of viewers around the world. Unitree's robots use a combination of advanced hardware and AI-powered control systems. Sensors placed throughout the robot's body constantly measure position, movement, and balance. Artificial intelligence algorithms analyze this data and adjust the robot's posture in real time. This allows the robot to maintain stability even when performing complex movements. Another major robotics company in China is UBTech Robotics. UBTech has been developing humanoid robots designed for industrial environments. Their Walker robot platform is intended to assist workers in factories and manufacturing facilities. These robots can transport materials, inspect equipment, and perform repetitive tasks alongside human workers. UBTech has even collaborated with international companies to explore how humanoid robots could support advanced manufacturing operations. The idea behind this collaboration is simple. Instead of redesigning factories to accommodate specialized machines, humanoid robots can work in environments designed for humans. Because their bodies resemble human bodies, they can interact with tools, machines, and equipment already used by workers. Another rapidly growing robotics company is Agibot. Agibot has been developing humanoid robots capable of performing tasks in logistics and research environments. These robots use artificial intelligence to interpret sensor data and navigate complex environments. Companies like Unitree, UBTech, and Agibot represent only a small portion of China's rapidly expanding robotics ecosystem. Across the country, more than 100 robotics companies are working on humanoid machines. Universities and research institutions are also heavily involved in robotics research. Hundreds of humanoid robot prototypes have been announced in recent years. Some are designed for factories and warehouses. Others are intended for research labs or service roles. This level of activity is unprecedented in the robotics industry. China's manufacturing ecosystem is one of the key reasons for this rapid progress. The country produces many of the components required for advanced robotics, including electric motors, sensors, processors, and batteries. This supply chain allows robotics companies to build prototypes quickly and reduce production costs. Lower costs make it easier for companies to experiment with new designs. Artificial intelligence also plays a central role in this transformation. Modern humanoid robots use AI systems to process visual information from cameras and sensors. These systems allow robots to recognize objects, detect obstacles, and plan movements. Machine learning enables robots to improve over time. Instead of relying entirely on pre-programmed instructions, robots can analyze the results of their actions and adjust their behavior. This adaptability makes humanoid robots far more useful in real-world environments. For example, a robot working in a warehouse must navigate around shelves, equipment, and human workers. The robot must constantly adjust its movements to avoid collisions and complete tasks efficiently. Artificial intelligence allows robots to interpret these situations and make decisions in real time. And this is only the beginning. At the same time, the global race to develop advanced robots is becoming more intense. Several countries are investing billions of dollars into artificial intelligence and robotics because these technologies have the potential to transform entire industries. Automation can increase productivity, reduce costs, and allow businesses to perform tasks that might otherwise be dangerous or difficult for human workers. China's rapid progress in humanoid robotics is part of this global technological competition. Countries around the world recognize that artificial intelligence and robotics could define the next generation of economic growth. Factories powered by intelligent machines could produce goods faster and more efficiently. Logistics systems could become more automated. Even healthcare systems could benefit from machines capable of assisting medical staff. This is why governments and technology companies are paying close attention to developments in humanoid robots. The potential impact is enormous. Imagine a factory where humanoid robots assist workers on assembly lines, lifting heavy components, transporting materials, and performing repetitive tasks. Imagine warehouses where robots navigate aisles, organize inventory, and move packages. Imagine construction sites where robots help transport equipment or perform physically demanding work. All of these scenarios are being explored by robotics companies today. Humanoid robots could also help address challenges related to aging populations. In many countries, the number of elderly people is increasing while the number of caregivers is limited. Robots could potentially assist with simple tasks such as carrying items, monitoring safety, or helping with household activities. Although these applications are still being developed, researchers believe humanoid robots could eventually support caregivers in certain environments. But as with any major technological shift, the rise of humanoid robots also raises important questions. One of the biggest concerns people often express is whether robots will replace human workers. Automation has historically changed the nature of work. Throughout history, new technologies have replaced some jobs while creating new industries. The Industrial Revolution replaced many manual labor tasks but created entirely new sectors of employment. The rise of computers automated many administrative tasks but also created millions of jobs in technology and software development. Humanoid robots could create a similar transformation. Some jobs involving repetitive physical labor may become increasingly automated. At the same time, new opportunities will likely emerge in robotics engineering, artificial intelligence development, software programming, and robot maintenance. Maintaining and operating advanced robotic systems requires skilled workers. This means education and training will play an important role in preparing people for the future workforce. Another interesting aspect of humanoid robots is how they interact with humans. Researchers are developing ways to make robots communicate more naturally. Some robots already use speech recognition systems that allow them to understand spoken instructions. Others use visual recognition systems that allow them to detect gestures or recognize objects. These capabilities could allow robots to work alongside humans more effectively. For example, a worker might ask a robot to bring a specific tool, move a container, or inspect a piece of equipment. The robot could interpret the request and perform the task. This type of collaboration could increase productivity while reducing the physical strain on workers. Instead of replacing human workers, robots might become assistants that help with physically demanding tasks. However, several challenges still need to be solved before humanoid robots become common in everyday environments. One major challenge is cost. Humanoid robots are complex machines with many moving parts, sensors, and processors. Building these systems requires significant investment in hardware and engineering. As production scales up, costs may gradually decrease. Another challenge is energy consumption. Robots must operate efficiently while maintaining balance and performing physical tasks. Battery technology will play a critical role in determining how practical humanoid robots become. Engineers are working on improving battery efficiency and developing more energy-efficient motors. Safety is another important factor. Robots operating near humans must be designed with advanced safety systems. Sensors must reliably detect people and obstacles to avoid accidents. Artificial intelligence systems must also make decisions that prioritize safety. Researchers are developing algorithms that allow robots to react quickly to unexpected situations. Despite these challenges, progress continues. Robotics engineers around the world are constantly improving hardware, software, and artificial intelligence algorithms. Each new generation of robots becomes more capable than the last. China's rapid progress in humanoid robotics suggests that practical applications may arrive sooner than many people expect. Machines that once struggled to walk across a room are now capable of navigating complex environments. Artificial intelligence is making robots smarter and more adaptable. Manufacturing capabilities are making it possible to produce these machines at larger scales. All of these developments indicate that humanoid robots are moving closer to becoming practical tools. Industries may soon begin integrating these machines into everyday operations. Factories, warehouses, hospitals, and research facilities could all benefit from robots capable of performing physical tasks, but the transformation will not happen overnight. Engineers must continue improving hardware durability, battery life, and AI decision-making systems. Robots must become more reliable and affordable before they can be widely adopted. Nevertheless, the momentum behind humanoid robotics is undeniable. Companies, researchers, and governments around the world are investing heavily in this technology. China's role in this movement is particularly significant because of its manufacturing strength and rapid innovation. The robots being developed today could shape the next generation of automation. They could change how industries operate and how humans interact with machines. But perhaps the most interesting question is how society will respond to these machines. Humanoid robots blur the line between traditional machines and human-like assistants. Their ability to walk, interact, and perform tasks makes them very different from earlier robots. Some people are excited about the possibilities, others feel uncertain about a future where robots work alongside humans. The reality will likely fall somewhere in between. Robots will not instantly replace large portions of the workforce, but they may gradually transform certain industries. The key will be how humans adapt to these changes. New technologies often create new opportunities, even as they disrupt existing systems. As artificial intelligence and robotics continue to evolve, society will need to develop new skills and new ways of working. And as humanoid robots become more capable, they may become an important part of that future. The question is no longer whether humanoid robots will exist in real environments. The real question is when they will become common enough that we see them regularly in workplaces and public spaces. China's rapid progress suggests that moment may arrive sooner than many people expect. And when it does, the world may look very different from today. Factories could include robots working alongside humans. Warehouses could rely on autonomous machines to move goods. Hospitals could use robots to assist medical staff. Even everyday environments may eventually include robotic helpers. The future of robotics is still being written, but one thing is becoming increasingly clear. Humanoid robots are no longer just a concept from science fiction. They are becoming real machines built by engineers, powered by artificial intelligence, and designed to operate in the same world that humans inhabit. China's humanoid robot boom is one of the clearest signs that the robotics revolution is accelerating. And if the current pace of innovation continues, the next decade could bring changes that once seemed impossible. The machines being built today may soon reshape industries, workplaces, and the global economy. The real question is how quickly that future will arrive. And when it does, how ready will we be to share our world with intelligent machines?